Welcome to my channel Electrotech Center. Today we are going to learn how to interface keyboard with PIC microcontroller. So we will start from schematic design first. So let's open Proteus software. So here you can see I have connected my keyboard with this microcontroller. So this first, second and third pin of microcontroller I have connected with RB0, RB1 and RB2 pin, and this upper 4 pin I have connected with RB3, 4, 5 and 6 pins. So you have to first understand logic of this keyboard scanning. So I have to send 0 on this first, second and third pin one by one, and I have to scan this upper 4 pin by using this PIC microcontroller, and I have to decide which key is pressed. So as per this logic or scanning we will decide which key is pressed, and that key we will show on this LCD. So I have connected here some pull-up registers because I have to read these pins through this PIC microcontroller. So here I have shown crystal circuitry which I have not connected to pin number 13 and 14. On Proteus it is not mandatory to connect this crystal here, but on actual hardware you have to connect this crystal and capacitor. And this is reset circuitry. LCD I have connected with port C and port D. So now we will see how to write code for this connection. So let's open MPLAB IDE. So in my previous video I have shown how to create project and how to add source file. So in this project I am not going to explain this procedure, so I'll just explain this code logic. So here first of all you have to include header file for PIC controller, which is xe.h. You have to set some configuration bits for oscillator, watchdog timer and low voltage programming. So this all thing I have explained in my previous video also. So these pins and this port D I have defined here for LCD pins RS RW enable. Port D is used for data pins of LCD. So this RB port I have defined here, RB port pins for keyboard interfacing. So R1 means row 1, row 2, row 3. C1 means column 1, column 2, column 3, column 4. As you can see here, there are 3 rows and 4 columns for this keyboard, which is connected with this port B. Next I have defined some functions here. So this function is for keyboard scanning, and these functions are for LCD. Inside main we have to set this add-convert register for our digital input output to pins. With C0, C1 and C2 we are using this C0, C1, C2 pin for RSRW enable pins of LCD. So that's why we are making it as output pins. This TSD register we are making 0 because this D port we have connected with data pins of LCD. That's why we have to make these pins as output pins. So that I have done here. This tris B0, B1, B2 I have made here 0. Okay, because this RB0, 1 and 2 I have connected with row pins of this keyboard. So I have to send data to this row pins. So that's why I have made that pins as output pins. And to tris B3, 4, 5 and 6, these pins I have to this pin I have connected with column of this keyboard. So that column pins I have to read. So that's why I have to make that pin as an input pin. That to input mode I have selected by setting these bits as a 1. So this was a configuration of registers. So first of all we have to initialize LCD. So initialization function sends some command to our LCD, which I have written here. You can see this initialization command 38, 0, 01 and 80. So after that, in while loop I am continuously setting my cursor to first line and first position. So first line first position means this is first line and first position. Here I am setting my cursor, and after that I am continuously scanning keyboard. So in keyboard function I will show keyboard function here. So I am making row 1 0 and row 2 and 3 pins 1. First thing we have to do that, and after making this setting we have to read column 1 2 3 4 pins. So if any button is pressed, this column pins will become 0 and it will respective button will show on LCD. So same thing we will do with row 2 and row 3. Okay, that is the logic for scanning keyboard. So that's how our code will work. So now we will generate hex file for our code. So here you can see our code is built successfully. So now we will load this hex file inside our microcontroller. So double click on microcontroller, select your crystal frequency here. You can give up to 40 megahertz to this controller. Select your hex file, click on OK. Now to see output you have to start simulation. So here you can see my cursor is on first line first position. So whenever I press first V, first switch, so that to switch will be displayed on this LCD. So like that, second, third, fourth, fifth, sixth, seventh, eighth, 9, 11, 12, 13. All uh, actually last key is 12. So like that you can write your logic whatever you have to show. So I am showing first key as a 1. So this is all about this keyboard interfacing and displaying on LCD. So in next video we will see how to interface 7 segment display to this microcontroller. So thanks for watching this video.